Okay, students, so welcome back to 2.1 about standard positions and reference angles. So if you have not watched your standard position angle videos before this, please go do so because if you don't, you're going to be pretty lost. Now, we've talked about standard position angles and how those things are formed between a positive x-axis and another arm where the vertex is found at the origin. Now, as you can see, it might get confusing always talking about angles in that manner because you're talking about big angles here. It can get a little confusing and hard to maneuver around. So that's where reference angles come in. Reference angles are very, very special. Now, something to note, the word reference. What does the word reference? The reference means something to look at to understand something else. So something to use to understand something else. So there's probably other types of definitions for the word reference, but that's kind of a Mr. Scaver layman's terms of what reference would mean, not an English teacher. So here we have our reference angles. Now, what is a reference angle? The reference angle is the blank angle whose vertex is the origin and whose arms are the terminal arm of the angle and the x-axis. So this would be known as the acute angle. Now, if you need to remind yourself what does acute mean, so what is an acute angle, that's okay. So something you learn, I think in either junior high or maybe even elementary is what an acute angle is. And the way your teacher probably describes it is it's cute, it's small. An acute angle is between 0 degrees and 90 degrees. And it actually won't equal 90 degrees though. So any angle between those two numbers, okay, that's an acute angle. So anytime you talk about a reference angle or you solve for a reference angle and you get a number bigger than 90 degrees, you've definitely done something wrong, okay? So something else about reference angles is they're angles that are always measure positive and are between 0 and 90 degrees. So those are two super special notes to talk about reference angles. So this is, again, saying that it has to be acute, and notice that it has to be positive. And if it's not positive, then you're doing something wrong. So let's see an example for this. So every standard angle, as we see up here, you can form a reference angle, okay? And what reference angles do is they are measured to the nearest x-axis. Okay, so that's another way to think about reference angles. So reference angles, actually it's stated right in the question. I don't know why I'm rewriting it. This is important. So these are the reference angles where the terminal arm of the angle and the x-axis forms your angle. So you're never going to make a reference angle that is made by the y-axis, it's always made by the x-axis. So let's look here. An angle of 30 degrees, sketch the following angles. An angle of 30 degrees, what angle does the terminal arm make with the positive x-axis? So again, we want to state all the useful angles here to get a general idea of where these angles might be found. So 30 degrees, well, that's between 0 and 90. And right down the smack dab middle of this, that would be 45. You don't have to draw that. So this would be 45 degrees. So the angle we're talking about will be a little bit smaller. And that will make our 30 degrees here. So I'm going to quickly erase this. So there's our 30 degrees. Now in this case, okay, our 30 degrees. Let's think about this. For right now, this is definitely a standard angle, okay? So this is a standard angle by definition. Why is it a standard angle? Because it's measured from the positive x-axis to our terminal arm. and our terminal arm has a vertex at the origin. Now, what would be the reference angle for this? So the funny thing about quadrant 1 angles is the standard angle is also the reference angle. And that only is true when you're dealing with terminal arms in quadrant 1, okay? So here, this really only will occur in quadrant 1, okay? Where your standard angle might be your reference angle. Anywhere else, your standard angle and your reference angle will definitely be different. Okay, so starting off with something that can be a little confusing at first. So let's look at B here. An angle of 150 degrees. What angle does the terminal arm make with the x-axis? So this sentence is essentially asking us, what is the reference angle? What is 150 degrees reference angle? That's another way to think about the question stated. So an angle of 150 degrees. So we got 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So 150 is going to be found near the middle between 180 and 90. So we will draw our 150 degrees roughly in the middle. So that will be a little bit closer to 180 degrees. And again, this is the standard angle. What is a standard angle? A standard angle is measured from the terminal arm to the positive x-axis. Now, we want to know what is the reference angle for 150 degrees. And recall to yourself what a reference angle is. A reference angle is where the vertex is at the origin, whose arms are the terminal arm and the x-axis. It does not have to be the positive x-axis, it's just the nearest x-axis. So here, we would not measure our reference angle to this axis because our negative x-axis is even closer. So my reference angle is going to be found here. Now you may ask yourself, how do I find that angle? Okay, well, some of you might see how you would do it, but recall that if I were to take this entire angle here, we know that entire angle. We know it to be 180 degrees. That's why we state this as 180 degrees, because all the way around is 180 degrees, or sorry, halfway around is 180 degrees. To figure out what this angle is, if we take off this 150 degrees from our 180, we're just left with what we need. So this will be 180 degrees minus 150 degrees. And what will that give us? Well, that will give us 30 degrees. So this here is our 30-degree reference angle. And I might state that as angle R, whereas I might state my standard angle as angle S. Okay, let's maybe state this in words. The standard angle of 150 degrees has a reference angle of 30 degrees. And our reference angle follows all the rules. It's making an angle with the nearest x-axis and the terminal arm. Origin points at 0, 0, and 30 degrees is between 0 and 90. So recognize this is an acute angle. Okay. So Hopefully that made sense. Let's maybe move forward. So maybe pause the video here and give C a shot on your own and see what you get. And I'll let you pause, give you a chance to pause for 3, 2, 1. And I'm gonna start how to do it. So I'll show you how to do this question. Hopefully you tried it out on your own. So sorry that this formatting got a little funky. So an angle of 210 degrees. What angle does the terminal arm make with the x-axis? Again, that definition in that little question there is essentially stating what is the reference angle. Okay, so 210, so hopefully you started off by stating 0, 90, 180, 270, 360. And now at this point, we are going to figure out and state where 210 degrees is found. So 210 degrees, that will be found between 180 and 270. So 180 and 210 degrees, so that will be roughly around here. A little less than half, between a little closer to 180. And again, that 210 degrees, we are talking about it being here. Okay. Now, where are you going to measure your reference angle from? Well, here, my terminal arm, what's the nearest x-axis? It would be this guy here. So now at this point, the question becomes, what is the reference angle for 270 degrees? And that will be this angle here. Recognize some people get confused and put it here, but remember, reference angle always has to be measured to the nearest x-axis. So I'm going to state this as reference or angle R. I might quickly put an S below here because that is the standard angle. And now we're dealing with my reference angle. Now ask yourself, how the heck are you going to figure this out? Well, remember that if we start at the positive x-axis and go halfway around, then you're dealing with 180 degrees, right? So this is your 180 degrees. In this case, you're trying to figure out how much this is worth. So if we take 180 degrees away from 210, then you are therefore essentially canceling this portion out and being left with the portion you want to find. So here, I will do 210 degrees minus 180 degrees. And what does that give me? That should give me 30. So there we go. So this will be 30 degrees as our reference angle. So it does take a lot of practice, if it's confusing at first, to figure out, do I add 180? Do I subtract it? What number do I subtract by? So on and so forth. And recognize that this is a positive number. Okay? So let's write it out. The standard angle of 210 degrees has a reference angle of 30 degrees. Okay, and there is our answer in writing. So if you have any questions, let me know on that. But if you feel confident, let's move on. So you can see here, you got a bunch of, you kind of have it now just written out. So the diagram below illustrates how we can find the reference angle in each quadrant. So remember, reference angle needs to be acute. That's always important to remember, and it needs to be positive. Okay, but they've generalized it for us nicely here. So remember, quadrant 1 has that special case where usually your angle is your reference angle. Over here, we can see that our standard angle is found in the red, so maybe I'll make a little legend here. So this is your standard angle. And then in the black, this is your reference angle. And we can see here that the red angle here is our standard angle, and you can find your reference angle by taking 180 away from the original angle. Okay, this one we never got an example of. As we can see, if our thing lives in quadrant 4, then we're actually doing 360 minus our standard angle. And that's because, recall that going all the way around like this, that's 360 degrees. So 360 degrees minus our red, we'll be left with that little piece there, which is our reference angle. So make sure you practice enough on finding reference angles. So let's look at example 3 here. So example 3, determine the reference angle for each angle. Sketch the angle in standard position and label the reference angle. So at this point, what do we want to do here? Well, we're trying to find the reference angle for each angle. They also want us to sketch. Even if it didn't say sketch here, I would honestly sketch it, because you need to get a rough estimate of what you're dealing with. So again, 0, 90, 180, 270, 360. Our standard angle is 140, so that's going to be found between these two values here. So my terminal arm will extend outwards, such as this, and my standard angle can be found at 140 degrees. Now, where is my reference angle going to be? Well, my terminal arm is closest to this x-axis. So at that point, this here is my reference angle. Now it's a matter of trying to figure that out. Well, remember, from 0 to 180, that's obviously 180 degrees. If we take this section away, we'll be left with our reference angle. So our reference angle will equal 180 minus 140. So that will become 40 degrees. So this is a 40-degree angle right here. Perfect. So there is our reference angle, and now we've actually labeled everything nicely. We labeled our reference angle and we labeled our standard angle. Okay. Let's give B a shot. Okay, so B here, our angle equals 320 degrees. So again, start off with a little diagram. Diagram in math will never hurt. It will always be useful. I can guarantee it. So we got 0, 90, 180, 270, 360. And then from here, 320 degrees, well, where's that found between? It's found between 270 and 360. Okay. The half of these two is 315. If you're wondering how I'm finding that so fast, that I know the half angle between these two things is 315, is all you do is you add up the two values and divide it by 2. Okay, that'll always find you the middle of two numbers. So that means 320 will be a little closer to 360. So roughly around there. And then I'm just going to simply delete this. Okay. It doesn't have to always be perfect in your diagrams, honestly. I'm never going to pull out a protractor and check or anything like that, as long as it's in the general vicinity of where it should be. So where is our reference angle? Our reference angle, maybe I should do it in green. Our standard angle is found right here. So this is 320 degrees. Now we want to find our reference angle. Our reference angle is measured from the terminal arm to the nearest positive x-axis. So here, there is our reference angle. Now we got to ask ourselves, how am I going to find this reference angle? Well, at this point, we are going to take 360, which is all the way around, and take away our green section to be left with our orange section. So our reference angle will equal 360 minus 320 degrees. And that will give us 40 degrees. So this is 40 degrees. So we have our reference angle now, and we have our standard angle, okay? So angle reference equals 40. And then over here, I think we actually got the same reference angle, which is kind of interesting, in totally different areas. Okay. So I'm going to pause the video there. I need you to go practice finding reference angles and doing some questions that are tied to that. Okay, so give it a shot, see how you do, make sure you understand how to find all reference angles before you jump into special triangles. Other than that, have a great day.